Let's get some background information about voltages due to alternating current sources. For most AC sources, alternating current sources, the voltages or the current are going to follow a sine wave function, and we can describe them with an expression similar to this. So in this case, the voltage as a function of time is equal to the amplitude Vmax sine of 2 pi ft. Now f is going to be the frequency of that alternating voltage, and t is the time. The maximum voltage is what we call amplitude, and sometimes we call it peak value as well. So the amplitude of the voltage is the maximum voltage. It is the peak value of the voltage as well. And the frequency is how many cycles per second is the voltage going to follow. If we are going to graph that, it's going to look somewhat like this, approximately. Okay, of course, this is supposed to follow a sine function. This is going to be my amplitude, or as we mentioned, it's going to be Vmax. This is going to be a period. It's also between trough and trough for peak to peak or any two identical points on the wave. So that's what we call the period, and the frequency is going to be 1 over the period. So by the way, I didn't draw the labels, I didn't write the labels for these axes, but the horizontal axis is time, and the vertical axis is voltage, if what we are looking at is a voltage, or the current is going to look the same way as well. Now, what we define as root mean squared is the maximum value of the voltage over square root of 2. So VRMS, or root mean square of the voltage, is Vmax, the amplitude, over square root of 2. Now, let's check some examples. If you are given something like this, and we are asked to find the frequency, the argument of the sine, that's where we have the frequency. So we go back here, and knowing that we have to change the color of the pen every time. So 2 pi f times t should be equal, that's the argument of the sine, should be equal to what we have in this case as 8 pi t. So solving for f, noting that t cancels out, the pi cancels out, and f in this particular case is 4. Now, if my frequency is 4 Hertz, then my period is going to be 1 over the frequency, which is going to be 1/4 of a second. Now, the maximum voltage is, we can read it off here, is Vmax is just 24 volts. Since remember, our expression is V of t is Vmax times the sine of 2 pi ft. Now, the next question is find the voltage at t equal 2.5 seconds. So we just plug it in. V at 2.5 seconds is going to be equal to 24 volts times sine of 8 pi times 2.5 seconds. 2.5 times 8, that's going to make it 2. So sine of 2 pi is 0, so we get 0 here. So the voltage at 2.5 seconds is 0. What's the RMS voltage? The RMS voltage is Vrms is just Vmax over square root of 2, which is in this case 24 volts over square root of 2, and we can calculate it if we need to. Okay, in this case, okay, let's see if I can pull in a calculator. Here's the calculator. So 24 divided by 2 square root of 2 equals 17 volts. Now, if I was asked to graph it here, at t equals 0, I'm going to have 0. Since my period is 1/4 of a second, so I'm going to have a full cycle by 1/4 of a second cycle here. So in between here, I'm going to have another 0 value. So I'm going to go up. I'm going to have a trough here. In between here, and a maximum here at 24 volts, and so on. 24 minus 24, etc. Okay, another example. Find Imax. So in this case, it's written in terms of the current. So Imax is just the 10 amps. We just identify it here from the expression. Again, we are relying on the fact that I of t is going to be Imax sine of 2 pi ft. Now IRMS is going to be Imax over square root of 2. So that's going to be 10 amps over square root of 2. So it's 10 over 2 square root of 2. That's equal to 7 amps.